we are doing another lead code question. And this is a hard question. It's called valid number, and it's lead code 65. And just one thing I want to mention here is, again, like we're going to be doing this the dry run interview style. What that means is I'm not going to be running the code while I am developing it. So how do we find bugs, right? Like we have to do dry runs, and we have to be mindful of how our algorithm runs without an access to a compiler to make sure that the code runs. And just for like a final check, we will run it in the lead code submission box. But the thing is, in an interview, you won't have access to that, right? So we gotta be, this is just for our sanity check sake. But yeah, so the idea is that we will be doing this right here in a sandboxed environment and without running the code. All right, let's read the question. So we are given a string s, and we have to return whether s is a valid number. So for example, the valid number is a single digit, multiple digits, negative numbers and decimals, positive numbers, 4.0, negative 0.9, and all of it. As we see, there is some scientific notation here as well with the use of e, right? And yeah, so the e could come anywhere in between the numbers. Well, basically it basically just means like 456 has to be raised to power of 789. I'm sorry, my throat is a bit itchy today. But we're still gonna do this. I hope it's not too distracting while we go through it. So I'm gonna be trying to talk. Well, I can't try talking less, but I'll try to talk softly. And yeah, so let's do it. Okay, so these are all valid numbers, right? It all makes sense. The numbers that are not valid are obviously the any digit other than E is not valid. For example, IA, IE. Why is IE not valid? Because after an E, we have to have another number here. Similarly, before an E, we need to have another number here. This, what is wrong with this? I believe it's because 2.5. I think for the purposes of this particular code, this is considered wrong. But normally you can raise a number to a fractional power. The double negatives, negative positive. So negatives or positive could only come at the beginning, right? So 95A, so there's an A and all of it. So, okay, so the number is, we have these sets of rules, right? Okay, the thing is, this is a simple question in the essence that there isn't a convoluted algorithm that we need to do. But the problem is we have so many edge cases and so many rules that it's going to be a hard problem because we won't have that much time to code it out, right? So that being said, what we can use is we can just basically use these codes, use these rules as our guiding point, right? So integer number followed by an optional exponent, decimal number, optional negative or positive, decimal number, the same thing, integer and decimal is the same thing, digits followed by a dot, digits followed by a dot, then followed by digits, a dot followed by digits, an exponent is divided in the e or e, small e or big E followed by an integer number. So this is the reason why 2.5 is not allowed. The digits are defined as one or more digits. All right, so starting from the beginning, let's look at a valid number, right? The first thing is we can have a positive or a negative. Positive or a negative. This is the only time where we will ever see positive or negative. It will be at the beginning of the string, not after, in case of a valid number, right? So let's just say a valid number is, let's just define this, def valid number, and we are given a string s. All right, so first thing we're going to check for is a positive or a negative. The next thing is decimal could be anywhere, but once, only once, right? If it is alpha, which means it's ABC, then it must be E or E, okay? And everything, no decimal allowed after E, okay? All right, so integer number followed by an optional exponent, decimal number followed by an, oh, what? Okay, so, I will be honest, I'm a little bit confused that this is not a valid number, but like, what does this thing mean? A decimal number followed by an exponential exponent. It doesn't really make sense, does it? But in any case, I'm gonna assume, because we can only assume in this scenario, but in an actual interview, you'll ask the interviewer which one to go. A decimal number followed by a exponential exponent, or 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 followed by an integer number. Or does it mean that after E there must be an int, right? Which basically means no decimals or no points. Right? That is followed by digits followed by dots. I think that pretty much covers all of our possible scenarios, and obviously we'll have multiple of those digits. So this is basically our guiding principle, like these four rules. And the thing is, the first thing we're going to do is, if S0 equals plus or minus, then we don't need to do anything for now, right? We'll just pass it. Or like S is going to be starting from 1 until the end. Okay, so we can just process it. Okay, the other thing is we need to ensure that if decimal used in the beginning, it will be false, but we can use it once, right? So every time we see a decimal, we're going to update this variable. And if the decimal is true, and then, we try to use it, then that's wrong. Okay. Honestly, I don't need to use this. Sign present, false in the beginning, and then I will set it to true. The reason being, I don't want to change the string over here, right? Because it's just like, of an operation for no particular reason. I can do the same thing in cheaper memory and time. Okay, and then here I have a decimal used. Yes, so what do we do now? So or start index, just again, I'm just making the code as simple as possible. So it's easier for us. Okay, so for I in range, start index, and length of s. Okay, so if s of I equals dot and decimal used is true, return false right away because we found the infraction. Otherwise, so I'm gonna nest it, because again, this is going to be a bunch of nested statements. So personally, I find it easier to ensure that each if statement is on its own line, so we can have corresponding else's, right? So we know that if a particular character is a dot, and if we have previously used it already, it's not a valid number, we return a false. Otherwise, we update the decimal used to true, so the next time we don't use it. Correct. So this takes care of our this rule, and yes. And now, in case this condition doesn't trigger, that means it's not a dot. In that case, let's check if this is a alphanumeric, right? So this is a alpha dot is alpha. So if this is alphanumeric, then we'll check if this is a E. Let's just do it like this. Or let's just lower it. And after lowering, if it equals E, in that case, continue, right? Otherwise, and the thing is, you can only use one exponent, right? So the same thing as the decimal use, we need to update that we only used one exponent. Otherwise, like if it's not any, obviously right away it's not a valid number. Now we gotta check if exponent used previously is true. That means we saw an E before. If that's the case, we can't have two E's. And we can't have two E's. That is the reason we did else. And nothing other than E allowed. Only one use of point, right? Okay, so this is that rule. Okay, now the other thing that comes to my mind is obviously to check if it's just a number, right? Like what does it mean by just a number? Just a number means that there should be only digits, nothing else. After the after like the specific case allowed, right? Um, so how do we do this? How do we do this? Let's see. Now, like the main thing that we have to ensure is that, especially after E, right? Like let's see, SI is E. Let's just take one example. Um, okay, let's just take this. Um, so we process this, it's fine. 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 Now we got to make sure that after an E, there is no decimal, right? So if exponent used, okay, if decimal used or exponent used, in that case, we should not, and no point after E. Okay, so that kind of takes care of it. Now, what we should do is basically have a catch all else condition. So how can we do it? We can either have dots, e's, or negative signs, right? Other than that, what else could we have? We could have digits. So let's do a alif. Let's do a alif. So in case this is digit, that's okay, right? That's fine. We continue on. But if it's not a digit and it's none of these things, that means something is wrong, right? Like there's some wildcard entry that shouldn't be there. So in that case, we return false right away, right? So again, this is a for loop, so we don't need to manage our I explicitly. But if the for loop runs and we don't return false, that just means it's a valid number. So we'll return true in the end. All right. So I think that is the entirety of code. And what we can do now is we can take a few examples and we can process it, right? So let's see this one. Let's see this particular thing. Okay, so there's a negative sign there. That is okay. My start index started with 0. I check if it's positive or negative. It's a negative. So what do? I update the start index to be 1. All right. So what basically happens now, essentially, I am ignoring this. So when my for loop runs, I'm going to be starting from index 1, which in this case is plus, right? In the beginning, we don't have any decimals. We don't have any exponents used. So what do? If s of I is a dot, it's not a dot. Then we check if it's ABC number. It's not. Then we check if it's a digit or if it's not a digit. Again, it's not a digit, right? So we will go in this particular if statement and then return false, because obviously we'll return false. This is an invalid number. And then let's see this. Oh, I think this might be a problem because I think I missed something. What I missed is E must have a num before and after. Okay. So obviously we missed it. So what we're gonna do is, before we do the E, we need to see if we have seen a valid number before, right? This doesn't make a number valid. This, what does num seen really mean? Does this mean that we have seen any single digit? For example, if I were to put, let's say, 0.1e, is this valid? Or 12e, is this valid? Or 1.0e, is this valid? 1.e x, is this valid? For the purposes of this video, I'm going to assume that these are all valid, where x is a int, right? I think the easier way to kind of do this is define either call this function recursively, but we have so much else going on, it might not be worthwhile to call this particular thing recursively. But maybe we can put this as recursive. Again, we probably don't want to do that either. Okay, so I'm gonna do one thing. I'm gonna make this a separate function so we can call this recursively. Uh, is this gonna work? We'll see. We'll see. So how do we do it? Let's just define a is valid function which will take the index I, which is our start index. It will take decimal used, and it will take exponent used. Okay. And I can move this inside. Okay. So in the beginning, obviously, we will start the is valid with or maybe this for I should be outside as well. Then this is just an I. So what I can do is I can check if a particular index is valid, right? Okay. Mm-hmm. Mm-hmm. The only thing I'm missing is here. What I want to do is have a start and an end index, right? Because that is what will make sense. But then the idea is like, if I have that, I probably don't need to. So for the time being, I'm basically gonna put a number here that, so put a comment here that it's signature to be refined, right? So how can I call this? Um, is valid, exponent used, but then yeah, I don't think I like the idea of that. I don't like it. I do not like that. There's a much simpler way, the way we did this earlier. And this is going to be that, right? So the only issue was exponent, right? Like if I have a e, I should have a bunch of integers right after it. What does that mean? Bunch of integers mean that only numbers and no decimals. But it can have a positive or it can have a negative. Okay. All right. So if the exponent is, if this is what happens after this, make sure everything to the end is just ints. One sign is allowed. Okay. So here we can keep running this entire thing if not exponent used. Um, so if no exponent used so far, we do all this. No returns here yet. Um, num seen. We should at least see one digit for it to be a valid number. Okay, so if no like if we haven't used any exponent yet, we'll do all this, and it will work. But if we have seen an exponent, in that case, we can again check if start index is da 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 da, that is fine. Start index is going to be I. And then this is no longer going to be a for loop because I have started manipulating it in the code. So what does I'm going to move it to I am going to move it to a while loop now. While I is less than length of s. And keep in mind here, if any of these conditions will happen, um, anything happens, I need to increment my I by 1. Okay, S is that, and can't have a decimal. So the only thing we can have is a, so S and I can only be a digit after this, right? Now there is gonna be another loop for I in range I towards length of S, right? If S of j is digit, is not a digit, then return false. Otherwise, we reached here. In the end, I is going to be equal to j. Okay. All right, so I think this should take care of it. All right, so now let's do 1e. 1e is invalid, right, as we know it. So our start index is 0. It's the sign is okay, so we don't need to change it. Decimal used false, exponent used false, num false, right? I is 0, it is less than s, and we haven't seen an e yet, so we check. Is it a decimal? It's not. Is it alphanumeric? Oh, sorry, is it an alpha? It's not. Is it a digit? Yes, it is. Great job. So then we put num seen as true, right? And in the next case, we do E. And here, this E gets triggered. Exponent used is fine. Numseen we have like exponent wasn't used before, so we set it to true. And awesome. And then we can just move that there. Exponent used is set to true. Um, then we check for the signage. Um, um, okay, exponent used is set to true. S of I, plus equals 1. Okay, so I is plus equals 1. And now here we need to make sure if I, in this case, is greater than or equal to length of S. In that case, we don't have anything behind it, so we will return false. Otherwise, if this doesn't get triggers, then we check if that is plus or minus. It is, then we increment by 1, and then we can only have 3, 4, 5, right? So we go in there. Towards the, here my I is here, I have the length of S, I run towards it, it is a digit. If it's not a digit, I return false. Otherwise, I is updated to like out of range index, and then this condition wouldn't trigger. Okay, so I think this should work. This is convoluted, and I believe there's a better way to do this. But this is my first time solving this question by my own hand, so this is what we came up with. Should be fine. Let's try running it. If it doesn't run, I'm probably going to cut the live stream and then come up with a recursive solution, which is basically going to be, it's going to call the is valid over and over for different values. All right. I'm going to share the, okay, I don't know how to do this. Okay, I'm just basically gonna change my screen with the valid number, and you guys should be able to see it now, but there we go. There we go, copy pasted. Doesn't seem like we have any obvious IDE issues. Syntax issues are normal, and we will not run into problem because of them. Where is the unindent? Okay, so this is going to be here. All right. Not too shabby. Okay, so exponent used is set to true. Oh, sorry. I made a boo boo with that in indentation. Okay, so this should take care of it. Cannot access local variable j. Okay, why do you gotta do me like that? Ha ha ha. This is again very bad code, but shush. Oh my god, I did not increment it. Oh, okay. I ran into time limit exceeded, which makes sense. See, like this is what I mean. Like this question is simple in practice, but simple in theory, but in practice, it's kind of hard, right? Now, if this doesn't run at all, then I also return false. Okay. Oh, so we cannot have. Why does this not work? All right, guys, I'll be honest, this is not a success, right? I obviously missed many of the use cases, many of the edge cases. So for that reason, I'm still gonna keep this live post up, right? But I'll probably revisit this question again with simpler handling. Okay. And I think the way I want to do it is have a simple method that checks given a start and an index that basically checks for this kind of thing, like this kind of thing. I think I can do a better job. So maybe right after this, or maybe not right after this, because like in my mind, like this code is fresh. So I guess tomorrow we're gonna do the same question again. Again, same format, same live stream, but like same coder pad without execution capabilities, but it's gonna be a different structure. I don't just want to do it iteratively. I want to pull in a recursive thing, right? So the way I'm thinking about it right now is going to be um, I can probably have this statement and yeah, so we'll have like a smaller function that can tell us if it's a valid number or not, given all of these flags. But in the main function, we will update the flags and it's all going to be wild so we can pass our indices. All right. Yeah, I'm not as happy with this code as I hoped, but like that's the point, right? Um, that is the point of this live stream, to kind of share both the good and the bad of lead code, and there is a lot of bad and lead code. Even like we're already at 45-minute mark, it's too long. In an interview, you won't be able to solve. I wouldn't have been able to solve it, so it's a good thing I am practicing now. All right, guys, I'll see you tomorrow, I believe, with the same question. In the meantime, hope you guys enjoy yourself. Bye.